All right, so hopefully technical things. I've got the room that I had planned to use yesterday. Everything's all set up. So hope everybody can hear me okay. I can hear, I used this earlier, so I know I can hear you. Excuse me if you talk to me, and I'll keep an eye on the chat. So we'll pick up where we left off in module one today, finish that up pretty quick, jump into module two. So before we do, all right, there is one thing I wanted to make sure I reiterate. And I don't, I my sections mixed up, so I can't remember if I mentioned this yesterday or not. But there is another section of this class earlier in the day. So if you do have conflicts, I think I mentioned this yesterday, you can watch live if you want to still, and you know you can't make the class at 2. 11:15, here's the Zoom link. I'll get an announcement up that also has the Zoom link, so you don't always have to go back to the week 1 slides to find it. The only difference is the join code will be for the other section, which is 4296. So I'll put all this in an announcement on Canvas so that you can kind of find it, always have it to go back to, but it's always going to be here in the slides as well, which I've replaced on Canvas to include this. They originally didn't have that. Yesterday, I kind of thought, well, give them some flexibility if they want to. If they're still attending a live lecture, it makes no difference to me. I'm going over the same material in both of them, so that's fine. We left off kind of thinking about this idea of marginal decision making, right? So we'll kind of pick up there. A couple other things I just kind of wanted to mention before we get started. We'll finish up module 1. And so I've got the module 1 quiz ready to go as soon as we're done with class. At the end of class, in fact, form out of this class, I'll hit publish here. That'll be due by the end of the day on Sunday. So even though this is meant for you to kind of follow along, I think it's best if you each day watch a recording. If you get, behind a little bit and have to watch 2 or 3 on the same day, I want to give you some flexibility in your schedule so that due date's a little bit further out there. Now, obviously, like for the next modules quiz, it'll also be due at the end of the day, Sunday. So I'm kind of doing this like week by week flexibility. And then that participation quiz, which we will have today, I'll publish it right now. We'll kind of look at some of those questions later on in class. That's now kind of under the module 2 material, which we'll pick up on here probably in the next 15, 20 minutes. Okay. Other than that, you go to the Files tab. For that first quiz, you have those practice problems. It'll really be questions related to kind of review of the syllabus, things about the class, but also some of the basic principles we talked about in module 1. So you've got some examples of what those questions will look like here. And then a similar thing for module 2, but remember I said I also kind of provide you with more worked out solutions. That quiz won't be made until we cover all of module 2 material, which should be the end of the day tomorrow. Okay. You also have that module 2 reading, which is due before we start class tomorrow. So these are the things that are usually due before we start covering that material, but with this first one giving you a little bit of flexibility. So on Thursday, when we start module 3, you need to make sure you have that module 3 reading done before Thursday's class starts. Okay. Also, I talked to the Top Hap representative, some of you who reached out about the e-text. They sent me an email this morning. They should have removed the paywall, that if you paid through the e-text through the bursar and through IU, that it should have given you access to that. So if you're having issues with that and it's still kind of prompting you to pay for it, please check it again today. Let me know if you're having kind of similar issues. Like I said, I was kind of assured that that paywall has been removed, but just wanted to kind of do my due diligence on that. All right. Any other questions before we jump into material here? The housekeeping stuff out of the way. Okay. So we kind of left off with this marginal decision making. In fact, we're going to jump right into today doing some work on this doccan. Okay. So I kind of ended last class. We were talking about this idea of when do we decide to do something? Buy another unit of a good, put another hour towards studying. We said as long as that marginal benefit is greater than the marginal cost. So what'll end up being true in subsequent chapters is we actually want to say people will go up to the point. So I continue to buy something or put hours towards something if the marginal benefit is greater than the marginal cost, up to the point where they are equal to each other. So if they are equal to each other, we'd say they'd still choose to go to that point because they're no better or no worse off. So we talked about this kind of in the context of, our net benefits, right? And I kind of had the little drawing where we were looking at the difference in marginal benefits, marginal costs. thinking about what our net benefits were. So I'm going to work through a little bit more of a detailed example of that. So it'll be a little bit review, a little bit of new stuff. So let's say I've got something here, and this can really be, usually think about this as the quantity of some good X. So this can be like the number of units I have of a specific product. We could also make this type of analysis with like the number of hours I put towards a certain activity. And really there, what we're measuring marginal benefits and marginal costs are going to be in terms of dollars. Okay. So let's say I had this example where, I don't know, let's do 1, 2, 3, 4, 5, right? And choose to buy 1, 2, 3, 4, 5 or something. The very first unit I have is going to have the highest marginal benefit. So maybe it's something like, I don't know, 19, and then at 2, I'll try to draw this to scale as much as I can. 3, 13, 4, 10, 5, 7. Okay. And then here I have an example where we're going unit by unit. So we've got, the integer values. But in practice, if this was like 10, 20, I can choose numbers in between, or I could buy, 1.5 of something, or put 1.5 hours towards something. So here's going to be the marginal benefit associated with each one of these different quantities. Now, we also at the same time would have marginal cost. So I think what I drew for you last class was a constant marginal cost. It could be the case here, what do I want here? That we have something like this, right? Where marginal costs are actually increasing. So if I think about in terms of hours, I give up my least valuable hour first, then my next least valuable. So the opportunity cost there, the marginal cost continues to rise, right? So I can kind of put some values to this. So we've got 8, I don't know, what do we have here? 11, at the third one. Well, this isn't going to be quite to scale here, but what? We'll do 12, 4, we're looking at 13, 5, looks like we're looking at something around 15. Okay. So it's the same, just to have some numbers, I want to show you something, another way of thinking about this. So there's a lot going on here, but really you don't have to kind of draw all these like grid lines, really just focus on kind of these 2 lines which represent the marginal benefits and marginal cost of this good. So we can think about, when do I choose to buy another unit, or when do I choose to put another hour towards this activity? Well, I can think about, I've got these different quantities. So 1, 2, 3, 4, 5. I can think about, for each one of these, I will choose to buy that first unit because the marginal benefit is greater than or equal to the marginal cost, right? That's what we were saying. Oops. Up here, right? So we kind of have everything on one screen. So I would choose to buy the first one. Would I choose to buy the second? Yes. Third? Yes. Fourth? No. There's another way we can think about this, other than just looking at the graph. We can look at the actual numerical values and say, what are the marginal benefits and marginal costs? And I will choose to do something as long as what we'll call the net benefit, which is the difference between the marginal benefits and marginal costs, is positive, right? Because anytime the marginal benefit is greater than the marginal cost, I would have a net benefit, or like the difference between the benefits and the cost would be a positive amount. I'd actually be better off. It's providing me with more happiness. So what would the net benefit of this first unit be? It's what? 11. Second unit, 11, 16, so 4. Third unit looks like 2. Fourth unit, well, there, 13 and 10. I'm actually at, the marginal benefits are below the marginal cost, so it's actually negative. Now remember, we said we wouldn't buy that fourth unit because the marginal benefit was below the marginal cost. Anytime that's true, the net benefits would be negative. And then out here we have what, 7 and 15. So I'm at what, -8. So if we were to kind of think about this in terms of net benefits, we end up making the same exact optimal decision, which is, as long as the net benefits are positive, I'm going to buy that unit of that product, or put that number hour towards a certain activity. As soon as it's negative, I won't choose to buy that one or put that hour towards it, right? So here, when the marginal benefit is above the marginal cost, I would choose to do that activity, either buy a good, put an hour towards something, and net benefits will always be positive whenever that marginal benefit is greater than the marginal cost. What would happen if the marginal benefit is equal to the marginal cost? Well, then my net benefit would be 0. But for the sake of this class, what we're going to do, we say someone will always go up to the point where that net benefit is 0, or up to the point where that marginal benefit is equal to the marginal cost, right? So in my example here, it's not technically 3. It would be like, 3.2 or whatever that ends up being. Okay. So just another way of thinking about it, a little bit more of a complicated model where the marginal cost isn't constant. Any questions on that before we keep moving here? Okay. All right. So let me get this out of the way here. So we went through that. So just to kind of round out or finish up chapter 1, more of some terminology stuff and kind of setting up what we're going to do throughout the semester. In economics, we have positive and normative statements. So positive statements, it's not like positive, negative. Positive just means it's what people actually do, it's facts. Or you can kind of think about it as it's usually something that we're looking at the data to report a certain number. So I might have some spending, household spending data, and I see that people on average in the US save approximately 5% of their income. That's just a fact. That's looking at the data. It is what it is. Now, the other types of statements we'll make are what we call normative statements. These are more like opinions, right? It's what people should be doing, or, so facts are positive statements, opinions are normative statements. So that might be, okay, I look at it, excuse me, and say, well, if people only save on average 5%, for most people that wouldn't be enough to be able to retire at 65. And so if people are wanting to retire at 65, they really should be saving more than 5%. But that's an individual decision, right? I'm making a judgment call. Maybe those people don't want to retire by 65. So I can make that statement that based off of, when I'm looking at this, I think they should save more than 5% annually to be able to retire by 65. But maybe people don't want to do that. Maybe their marginal benefits of working are different than yours, right? So we've got positive, normative statements. Positives are fact, normative opinions. So normative economics, well, that's just like your opinion. So I'll use cheesy memes also to kind of let you know of amazing movies. So if you haven't seen The Big Lebowski, great cult classic. It kind of, it's a different type of humor, but give it a shot. Maybe if you haven't heard of it yet, right? So with this idea of facts and then making statements that are a little more subjective, economics still is a science, right? So it's like not like physics or chemistry, but it's a social science. And so we still follow the scientific method. So we're going to develop a model or a theory about how or why things are working. We then have some type of an experiment that we're going to use to test this theory. Now, usually these experiments are just people living their everyday lives or firms making everyday decisions. Now, there are economic experiments that they like set up in a computer lab to try to analyze individual decision making, which are very interesting. We won't really talk about those in this class, but I might mention some here or there. But usually it's going to be like people just looking at the experiments that are run in everyday life. We're going to collect data. So maybe this is looking at people's spending data, right? Looking at credit card data or bank account data. So once we have this data collected, we're then going to use this to test our models, right? If it's consistent, great. If not, we might need to revise our theories, go through this process over and over, right? So what does this kind of look like in practice? Just to kind of give you an idea. Well, anytime we have a model, we're usually trying to isolate the cause of something. So if prices go up, do people buy more or less? Well, if prices go up and income goes up, it may not seem as obvious, right? So if I have more money and prices are higher, if my income went up by more than the prices did, maybe I still buy more, right? So what we're wanting to do in our models is kind of ceteris paribus, which is Latin, means hold everything else equal. So we want to get at causal relationships, the effect of this X variable on this Y variable. Like I said in the example I was giving, the effect of a price change on how much people are buying. but we need to hold everything else constant, like income, market conditions, maybe trends for if it's a certain product that all of a sudden becomes trendy, like I don't know, fidget spinners or something stupid like that that has a moment in the sun. We're holding all those other things constant, right? So we really want to isolate the effect of just one variable. Okay. So usually, we have these models. If we're assuming everything else is equal, we know that in reality, things are always simultaneously or constantly changing. So it's really hard to hold these other things constant. Our models will assume that they're held constant, and then hopefully we come up with a good way of designing experiments that do hold them constant and only allow the one thing to change that we want to know the effect of. So we want to look at cause and effect relationships. We have to make some of these simplifying assumptions and that everything else is being held constant. We'll test it with real world data. So because it's real world data and we aren't able to hold everything constant in the real world, we should probably kind of take some of what we see with a grain of salt or question it. Here, I'll give you kind of an example of this with financial returns from a college degree. So this is an article, I believe, that kind of talks about, assessing what is the real value of a college degree, right? You're all here trying to get one. Why are you doing that? I assume it's because you think it'll get you a higher paying job, right? Especially since you're in the business college, a little bit more monetarily minded, maybe not just get a job that you enjoy. Although if you're maximizing your self-interest, maybe it's not just money, maybe it's getting a career that you really enjoy. So just to kind of think about the scientific experiment in the context of this type of a question, we could maybe say, okay, what's the effect of one more year of education, right? Well, there's an old theory that says every year of education, every year of college you take, you get a 50% increase in, I don't know. Actually, I think I have this set up this year. Yeah, let's do this as like an actual college degree, right? So you might say that it increases it by 50%. I went out and got some data, and I think it's from the BLS. I've got the link here in a second. I'll verify that. So anytime I give you some of these real world numbers, I try to give you the links as well, just to be kind of do my due diligence if you want to go look at the actual data. So the average starting salary, or average, sorry, weekly salary of someone who's older than 25 is $1,400-ish. And the average weekly salary in the US of someone over 25 with a high school diploma from this data set, and I forget the exact time frame, and it's a little bit older data, was $850. So I might look at this and say, okay, look, over 4 additional years of education, right? If this is the difference, right, that this college degree, right, I'm making about $600 more. Well, that kind of sounds similar to something we already talked about, which is like the marginal benefit, right? So, right, if I get a college degree, it's not that the marginal benefit is $1,400 because it's the change in my benefits, right? If I didn't have a college degree and only had a high school diploma, I'd still be making $850. So the kind of additional amount I'm earning is 600. Now, if I want to kind of put this in terms of a percentage, right, I'll take the ratio of those two and I see it's about a 68% increase. So that's not quite consistent with my model, right? My model predicted that this college education would increase my earning potential by 50%. I found here that it's actually 68%. So maybe I need to revise my model a little bit. And this is kind of the idea of having a theory, going out, looking at people actually running the experiment, getting an education and then getting a job, and then using that, collecting that data and using that data to verify whether or not our model needs to be changed. Okay. So here's the link. Like I said, you can kind of go check out. It's got different age categories and years of education. You can kind of, if you're interested, play around with that. BLS has a whole bunch of interesting labor market data out there. Okay. All right. It's nothing too crazy here, but we're testing these models. One thing we also want to kind of keep in mind, a lot of times when we make statements throughout the semester, we're going to be talking about the average effect, right? So this wage increase that I just mentioned, well, yeah, it's the average increase, right? So for some people, the value of a college degree won't be as great as for others. So maybe you can think about, I was walking around campus here, that felt like a Disney convention or something. Not to pick on this type of a major, but my guess is the returns to a finance degree, marketing degree, all the degrees within Kelly might be more than 68%, right? This was the average effect. So it might be more than that. I'm guessing for a theater major, maybe not quite as high, right? Now, there's also people who only had a college degree. They're going to skew the data. Someone like Bill Gates or Zuckerberg. Well, okay, you got a college degree, but I mean, I can't expect the same increase in my average weekly wage as they are. So whenever we make statements about these cause and effect relationships, it's always going to be based off of like the average effect. Right? So we want to know what the causal relationship is. Another thing that we want to be concerned with when we're talking about these different models or be careful with, and this is the whole reason why we do that ceteris paribus, hold everything else constant, is sometimes we'll see something that looks causal and it's actually just evidence of a correlation. So an age-old example of this is like ice cream sales and drowning deaths, highly positively correlated. I don't think anyone's going to try to argue that, well, maybe someone would say, kids eat too much ice cream, then they sugar high, when they crash, they're more likely, I don't know, to drown. I don't think that there's any validity to that. What's really going on here, right? Ice cream sales aren't causing children to drown. It's that something else is causing both of these, right? So when it's hot out like today, people are more likely to be buying ice cream and people are more likely to be swimming. So we'd see both of those things go up. So if we don't hold that additional variable constant, we're not going to get the correct causal relationship. Now, I just say all of this to say some of the things that we talk about throughout the semester, we are really going to isolate and talk about causal relationships. When we look at the actual data, we can sometimes see not everything is being held constant, and we might see some correlations that look like they don't kind of line up with our models. That's not necessarily the case if we aren't holding all these other variables constant or all these other things constant. So we won't really dive into too much about how we do that in terms of the real world data, how we use the real world data in this class. I forget what the stats equivalent is. I know in the econ department it's 370, but there's courses that you'll take while you're here, stats courses where you talk more about how do you ensure or how do you hold those other things constant and how do you get a causal relationship instead of just a correlation. Okay. So that should kind of wrap up module 1. So it'd be relatively quick here. So we're done with that, right? I've got that first quiz. I'll just kind of publish it right now. Be due by the end of the day on Sunday. So you've got some time to kind of think about when you want to study for that using those practice problems and when you sit down to take it. Now, once you start, you'll have 60 minutes to complete it. So I, don't like pull it open right now. It's once you start the clock is running and you'll have 60 minutes to complete that. But you can start that clock at any point. Okay. Any questions from me before we jump into module 2 here? Oops. Okay. Nothing in the chat. So module 2, right? So, whoop, I hit the wrong arrow. So module 2 is essentially we're going to be talking about something that's called the PPC or production possibilities curve. I think some other books, or if you're looking at other materials, might call it the production possibilities frontier, but it's really referencing the same thing. Okay. So we're going to start out with thinking about we have one country or one economy, and this we can actually look at this at an individual level as well, but all the examples I'll use today, we're kind of looking at like an economy-wide production possibilities curve or thinking about a country. So they've got two goods they can produce, and they face the main economic problem, which is I want to produce these two products. I have a limited or scarce resource. Here, we're just going to use labor. We'll ignore raw materials for a second. We're only using two goods. Obviously, countries can produce thousands of goods. It's the same concepts. The math just gets harder. We need matrix algebra and things that we're not going to use in this class. So anything that we look at, I'll kind of keep it at these two good models. So they have this scarce resource of labor, and they can take it and put it towards the production of computers. When I put produce here, I probably should change it. I think I changed the example, but an agricultural product, and then I think the example I use later on in the slides is wheat, right? So I've got 50,000 labor hours, and I've got this kind of setup where every computer, right, would require 100 labor hours, and every ton of wheat only requires 10. So this is kind of like the number of hours required to get one of each of these products. So if I put all of my labor hours towards computer production, how many total can I get? Well, 50,000 right here. Each 100 labor hours gets me one computer. that would be what, 500 computers, and I'm putting nothing towards wheat, so 0 hours of wheat production, or 0 hours, 0 tons of wheat production. I could also look at the other extreme. Get this out of here for a second. If I put no hours towards computers, I'm going to have 0. If I put all of my labor hours towards wheat production, well, if each 10 hours gets me a ton of wheat, that would be what, 5,000? And then we've got 3 other points here in the middle, which are going to be that I don't only produce one good, I produce a combination of these 2 goods. So if I put half of my labor hours towards computers, half towards wheat, I'd have 250 computers and 2,500 tons of wheat. So these are all points that are possible for me to produce given how many labor hours I have. How we choose which one is best, that's something we'll save for kind of next class. But here we're just trying to understand, I put a certain number of labor hours towards the production of each of these products. Here's the different combinations I could get. Okay. So how am I going to look at this in graph form? Right. So let's see here. Make sure it's kind of straight. So I'm going to choose to put the computers. So I put PC for computer. If you want to route the word computer, you can. I'm going to put that in the x-axis, and I'm going to put wheat on my y-axis. Okay. If I'm putting all of my labor hours towards wheat production, we said we could get 5,000, but no computers, and then only towards computer production, 500 computers, 0 tons of wheat. So these intercept values represent how much I can produce of that product if that's the only thing I'm producing. And then I think the points, usually, as long as we have those 2 points, there's going to be a trade-off, right? As I want to produce more computers, I have to give up the production of a certain amount of wheat, right? So if I wanted to do 100 labor hours towards computers to get one more computer, well, if each ton of wheat was 10 hours, I'd have to stop producing 10 units of wheat. So these other points that we had here were what? 2,500 and 250. I think this one I gave you was 4,100. And then the other one down here was 400 and 1,000. Right? So using those points, right? Those aren't the only 5 combinations I can produce. I could really produce any combination in between those as well. So we're going to have this curve. There's no curve to it yet. It's just a line, but this will be our production possibilities curve. It just represents the different combinations that I can produce of this product using all of the resources that I have. Okay. Any questions there before I keep moving? Okay. So I'm going to jump the gun a little bit into the slides, but I'm going to kind of do all the work here first. I think that'll make sense. So if I'm looking at this, I already kind of mentioned when I want to produce one more computer, how much wheat am I going to have to give up, right? Because if I'm using all of my resources here to produce wheat, to get one more computer, if I were to kind of continue to produce the same amount of wheat, I don't have enough resources to do that. So I've got to give up some wheat production. So how much is each computer going to cost me? Well, that's essentially, what does the slope of a line represent? So if I have y equals to mx plus b, that slope represents how much y is going to have to change by anytime x goes up by 1. And it's a downward sloping line, so we know that this slope is going to be negative, right? There's a trade-off between producing one of these goods or the other. To produce more computers, my opportunity cost is I have to give up the production of wheat. So how do I calculate the slope of a line? This is just change in y over change in x, right? What's on my x-axis and what good is on my y-axis. So here, I could choose any points on this curve to calculate the slope. I think the easiest one is just to choose the 2 extremes, right? So how much is y changing by if I move between these 2 intercepts? Well, it's going from 5,000 to 0. So what? Negative 5,000. How much is x changing by? It's going from 0 to 500, so 500. So I get a slope of negative 10. So anytime I calculate the slope of this production possibilities curve, what it's telling me is if X goes up by 1 unit, how much is Y going to go down by? Essentially, it's the cost in terms of the Y good of getting one more of that X axis good. So my slope in these production possibilities curves is the cost of our X axis good in terms of our Y axis good. Okay. So in our context, the cost of one more computer, the X axis good, is going to be, I have to give up, or the cost would be 10 tons of wheat. Okay. Any questions here? Okay. Now, another way of thinking about this, so we've got the cost using the quantities, but remember, where did these quantities come from? It came from that I could only produce a certain amount of these goods because I only had 50,000 labor hours. So if you go back and remember, how much did each computer cost me? 100 hours. How much was each ton of wheat? We said that was going to be 10 hours. Notice how many tons of wheat could I produce instead of one computer, all right? If I was producing one computer, how many tons of wheat could I produce if I was using all 100 labor hours towards wheat production? Well, 100 over 10 would be 10 tons of wheat, which is the exact same thing as the cost that we determined using just the slope, using just those quantities. So typically, you'll have the quantities and you calculate the cost of your x-axis good by using those quantities to calculate the slope. But I just want to make this connection that these quantities are really being driven by whatever that ratio is of how much of that resource, that scarce resource you need to produce each of these products. Okay. Any other questions there before we keep moving? Okay, so extending this, if the slope tells me the cost of my x-axis good, what's a way that I could find the cost of not one more computer, but one more ton of wheat? Simply flip where these goods are on the axis. So I'll do that for you, and then I'll show you a shortcut that you're not going to have to draw this out every single time to determine the cost of both goods. So we already have the cost of a computer. If I wanted the cost of one more ton of wheat, I need to put wheat on my x-axis, right? Because the slope of my production possibilities curve, the slope tells me the cost of that x-axis good. Okay, so now wheat is 5,000. PCs, we had 500. What would my slope be here? Negative 500 over 5,000, or negative 1/10. So you'll notice when I flip these, maybe, I don't know everyone's math background, but if I'm flipping the axes, what am I really doing? The slope will be whatever it was before, but it's simply the reciprocal of that. So notice I could draw out the production possibilities curve and switch what good is on the x-axis, and then I'll see, okay, now the slope tells me that the cost of one of my x-axis goods, so 1 ton of wheat, is 1/10 of my y-axis good, or 1/10 of a computer. Or instead of drawing it out every single time, if I originally find the cost of my x-axis good, and then from there, I want to know what's the cost of my y-axis good, it's simply going to be 1 over the cost of my x-axis good, or 1 over that slope. Okay. So this is kind of the shortcut that I think is probably easier to do once you have that, that rule. There's no sense in, it's under here. There's no sense in, drawing the production possibility curve out again, flipping the two goods. But if this way makes sense and it's easier to not make mistakes, by all means, you can do this every single time. But notice you would end up with the exact same value. Okay. Any questions on that idea before we keep on moving here? Okay. All right. So got our graph down, talked about these opportunity costs. So really what these slopes represent at the end of the day, where it's how much of the other good I'm giving up. So what I'm giving up or foregoing, that's my opportunity cost. So we said the slope, which is always negative, right? That'll be the cost of the x-axis good. So I throw a negative sign in front of there because usually when we talk about cost, we wouldn't say the cost is negative 10 computers. We're already saying it's a cost, so it's kind of implied that I'm giving up those 10 computers or 10 tons of wheat to get that additional computer. So if I want the cost of my y-axis good, just as a more general form, it was 1 over that slope. I talked about that. So our example, right, we had the cost of one more computer was 10 tons of wheat, making the opportunity cost of a ton of wheat 1 over that, or 1/10 of a computer. And the costs are always in terms of the other good, right? How much of the other good do I have to give up? Any questions on that? So that's one country, right? When we're looking at, let's say like the worldwide economy, we have multiple countries, right? And we know that different countries are going to have different costs, right? So before we go to countries, you can even just think about how costs vary. So let's think about like the CEO of Ford, right? If they could fix their car, I don't know if it's a he or she, I don't even know who the CEO of Ford is right now, but let's assume that they could fix their own car in 1 hour. There's a mechanic who could fix the car in 3 hours and charges $200. Should the CEO fix their own car or pay the mechanic? Well, they can do it in a shorter amount of time. However, if they don't fix their own car, what is that CEO using that hour to do? I don't know, work for Ford, earning them lots of money and then being compensated. So maybe the CEO's time is valued at $2,500 an hour. Well, going back to if the CEO is making a self-interested and rational decision, if they fix their own car, they're going to lose out on $2,500. If they work and pay the mechanic to do it, they still have $2,300. Which of them makes them better off? Paying the mechanic to do it, right? So here, costs matter, right? It shouldn't just be who can do this with fewer resources, right? So the CEO is using only 1 hour as opposed to 3, but it's who has what we'll end up calling the comparative advantage, right? Whose opportunity cost to doing this activity is lower. And in this case, the mechanic has a lower opportunity cost than the CEO. So this then introduces the idea of some terms that I'll be kind of using, which is absolute and comparative advantage. So in our example, right, who had the absolute advantage in fixing their car, right? So an absolute advantage is simply if I'm using the same number of resources as the other person, the other firm, the other country, I can produce more of that good. So let's say we had, the US and Canada, and they're using all their resources to only produce something stupid like, I don't know, TikTok videos. The US might have an absolute advantage because they have more people, they could produce more. Right? But it's not just they have more people, it's if they use the same number of people, they could produce more. Okay. And then in our example, the CEO, right, could fix the car in fewer hours. So if he was putting 3 hours towards fixing cars, he could fix 3. The mechanic can only fix 1. So we would say the CEO has an absolute advantage in fixing that car. Now, comparative advantages, who can do this at a lower cost or who can produce this good cheaper is a less technical way of saying it. So in our example, it would be the mechanic, right? Because their time was less valuable. The opportunity cost to them, even though they were giving up more hours, the value of each hour was much lower than the CEO. So what does this look like in the context of the choice between producing two goods and comparing, say, different countries? And this could be two firms or two individuals as well. I just decided to go with a country example here. So let's say the US and India can produce two goods. And once again, we know that these countries are producing more than two goods. We're simplifying it. I'll never ask you to do more than two, but if they were just producing two goods, right? iPhones and aircraft parts, and if they put all of their resources, they could produce the following. So usually I'll kind of give you this more in like word form, but that, we're doing it in slides here. So this table represents if this country is using all of their resources to produce iPhones, they can produce 60. If they're using all of their resources to produce aircraft parts, they can produce 30. And obviously in the real world, this is millions or whatever it is. We just want to make the math a little bit easier. If India puts all of their resources towards iPhone production, they can produce 50. If they only put their resources towards aircraft part productions, they can produce 10. So this is kind of our setup. What we could do is essentially, what do these points represent? They would represent the intercepts of each country's production possibilities curve. So I'm going to, oh, sorry, I almost jumped the gun. I forgot there's an additional question before we get there. So those are the intercepts, right? Who has an absolute advantage in iPhone production? Well, using all of their resources, the United States can produce 60 iPhones, India can produce 50. We would say the US has an absolute advantage. Who has an absolute advantage in aircraft part production? Using all of their resources, the US produces 30, India produces 10. We would say that the US has an absolute advantage. So a country, a person, a firm can have an absolute advantage in the production of both goods, like the US, neither good, like India, or in different examples, like maybe instead this was 80 iPhones, well then each country would have an absolute advantage in only one product. All of those are possibilities. So this is just one example where one country has a comparative advantage, or sorry, one country has an absolute advantage in the production of both goods. It doesn't have to be the case. It can be that each has an absolute advantage in only one of these goods. So this is where I was jumping the gun. We can take these values. These would be the intercepts for our production possibilities curve. So here I've got the US. If they're only producing aircraft parts, 30, iPhone 60. India only producing aircraft parts, 10, iPhones 50. We then kind of draw a line between those two intercept points. Now we'll notice if we do draw this out and have a visual, it's very easy to see who has an absolute advantage because it's whoever has the higher intercept. So if I look at the intercept value on the x-axis for iPhones, who has a higher amount that they can produce? The US. What about aircraft parts? Also the US. Okay. So the intercepts tell us something about the absolute advantage. What would tell us about the comparative advantage? Well, we said the comparative advantage is who can produce this good at a lower cost. So if I'm thinking about this visual and I want to know who can produce iPhones at a lower cost, right? Whoever can produce them at a lower cost, we would say has the comparative advantage. Well, which of these curves, if I've drawn them to scale, do you know is going to represent a lower cost to iPhone production? So the flatter the slope, the closer it's getting to what value? 0. So the flatter slope should represent a lower cost. So here, before we even work through the math, it should be that India has a lower cost to this x-axis good or a lower cost to iPhone production. So they should have a comparative advantage in iPhone production. Okay. We can use the actual values to determine this though, because the slope of each one of these, for the US, if we use the extreme points, what's the change in y over the change in x? Well, y is going from 30 to 0, so negative 30. X is going from 0 to 60. 30 over 60, or negative 30 over 60 is negative 1/2. So each iPhone is costing the US 0.5 aircraft parts. For India, each iPhone is costing them what? The change in y is 10, change in x is 50, so 1/5, right? So 1/5 is 0.2, just to, we're not talking in fractions, we're making it a little bit clearer. Who has a lower cost to producing an iPhone? Well, it costs the US half an aircraft part, only cost India 1/5. The cost is going to be lower for India here. So we would say for iPhone production in this example, India has a comparative advantage. Okay. So kind of taking what we already did, we're just doing it kind of for two countries at the same time, and then looking at that slope, which represents the cost to each country, to determine who has that comparative advantage. Okay. Any questions on that before we keep moving here? Okay. So we already determined India has that comparative advantage in iPhone production. What if we wanted to know who has the comparative advantage in the other good, right? Aircraft part production. Well, remember, if I want to know the cost of my y-axis good, I could flip these goods, recalculate the slopes, and then compare. Or the cost of my y-axis good should always be 1 over the cost of my x-axis good. So if we take that, right, 1 over 0.5 would be 2 iPhones for the US, 1 over 0.2 would be 5 iPhones for India. Who has the comparative advantage, in aircraft part production? Well, who is producing at a lower cost? That would be the US. So here, you'll notice the comparative advantage. Each country only has a comparative advantage in one good, and that will always be true. So why? Well, here, if we think about, so I have the cost of my iPhones, it was what, 0.5 and 0.2 for the US and India, right? So anytime someone has a lower cost or the comparative advantage in the x-axis good, well, how do we find their cost for the y-axis good, or the cost of an aircraft part? Well, it's going to be 1 over the cost of the x-axis good. So you may not remember this, but if I have, 0.2 is less than 0.5, when I take the reciprocal of each of those, 1 over 0.2 will always be greater than, right? Because my denominator is going to be lower here. It'll always be that India then ends up with a higher cost to that y-axis good. So I can only ever have a comparative advantage in the production of one of these goods. Okay. Any questions on that? It's a little bit tricky, so I don't want to move too quick here if someone needs clarification. Okay. Just to, sometimes this will help people. If it doesn't, then you can just throw this out of your mind. But I think for some people, instead of looking at a graph, I don't know, I always kind of liked this when I was learning this material. So if we go back and remember, so this was what, 60, 50, 30, and 10. These were the original numbers we were given using all of our resources, how much the countries could produce. If I want to know the cost, why did I put AD? It's like, didn't make my P large enough there. There we go. If I wanted to make or know the cost of one, let's do aircraft part. So let's say I want to know, instead of drawing it all out, calculating the slope, I can always do it this way. If I want to know the cost of one aircraft part, how do I make this a 1? Divide it by 30. But if I divide this by 30, I want to scale this one as well. Notice, oh, the cost of one aircraft part for the US is 2 iPhones. I can do the exact same thing. If I want to know the cost for one aircraft part for India, I can turn it into a 1. Well, if I divided this by 10, I need to scale this as well. Oh, sure enough, one aircraft part would cost India, or sorry, aircraft part would cost India 5 iPhones. So I can use this method as well if this kind of lines up with your thinking. And it'll then give you the costs, who has the comparative advantage. Well, the US has a lower cost, so the US would have a comparative advantage in, well, what were we looking at producing? One more aircraft part. So they have a lower cost to aircraft part or a comparative advantage in aircraft part production. Okay. Any questions there before we keep on moving here?
And you can do that with everyone.
Yeah. Let's say I wanted to know the cost of an iPhone. So let's say I had those same values. All right. This is kind of light. I think I grabbed the wrong marker here.
I'm talking about like a whole different like graph, like a whole different number.
Yeah. As
Oh,
long as you're
wait,
turning whenever you want to know the cost of into a one,
into a one.
always do this method, right? So let's say I want to know the cost to the US of one iPhone. Divide this by 60, which means I have to divide that by 60. And sure enough, I get, oh, the cost of one iPhone to the US was half an aircraft part. And it doesn't matter if this was 80 and 20 or whatever the numbers are.
Sweet, thank you.
Yep. And if you said sorry, don't apologize. It's good to ask these questions. Couldn't hear if you said sorry or sweet. So, any other questions on this before we keep moving? Okay. All right. So this is where we'll skip ahead here. And I'll pull open the quiz for today. So two of these questions we should be able to now kind of reason through. Excuse me. So this first one, if I'm using all of my resources, so this is like a 1700s economics example where you can produce military products, so guns, or agricultural products to feed your people. So guns and butter is like an old example they use in economic literature. So if I'm only producing guns, how many can I produce? Well, the intercept values tell me if I'm using all of my resources just to produce that one good, that's how much I can produce. So here, if I'm only producing guns, I could produce 600. If I was only producing butter, 800. So here, 600 should be our answer. Right? Oh, in fact, I can actually do it this way. So I don't give you the answer before I give you the answer. Right? So 600. What about here? What if I wanted to know the opportunity cost of producing one more unit of butter? So if I want the opportunity cost of the x-axis good, what do I need to do? Simply look at the slope of the production possibilities curve or the production possibilities frontier. I stole this from an old textbook. So what's the change in y? It's going from 600 to 0, so negative 600. Change in x going from 0 to 800. So 600 over 800 would be what? 0.75. Now here, in terms of costs, right? We drop the negative sign. The slope will always be negative for these production possibilities curves because we always have to make trade-offs. When we're talking about it in terms of a cost, it's already implied that it is negative, so we're just going to put in kind of 0.75 here. Okay. So if I'm asking you for the cost of that x-axis good, there's no need to put a negative sign there. Any questions on that? Should be pretty simple based off what we've talked about. So the next thing that we're going to want to go through today, and there's still one more question in that quiz that we'll cover here in a little bit, but let's go back to our example with the US and India. So we now kind of have all of their costs, right? Their cost to aircraft parts and their costs to producing iPhones. So, depends on who you listen to. But if you listen to an economist, trade is generally always a good thing, right? So there's always going to be gains from trade, and we can kind of work through some pretty simple examples to show that, right? So let's think about these two countries, and if they're operating independently, we know how much of each of these two goods they could produce using all their resources, and we know their own costs. So how many iPhones would India be willing to give up to the US to get an aircraft part? Well, if India wants to produce an aircraft part, the cost to them would be what? 5 iPhones? So if they wouldn't be able to produce 5. So if they give up anything less than 5, they're actually better off. They could get that aircraft part if they only had to give up 4 iPhones to another country, they'd be better off than if they produced it themselves. So India would be okay trading any number of iPhones for an aircraft part less than 5. Now, how many would the US be willing to accept? Well, if the US, right, wants to produce, the US produces one more aircraft part, how many iPhones are they giving up? Right? So one more aircraft part, they're going to have to give up 2 iPhones. So if they're producing an aircraft part for someone else, they better be getting back more than 2 iPhones. Otherwise, they should have just produced it themselves. So for the US, they'd be willing to take anything above their own cost, which was 2. So if they can come to an agreement on the terms of trade being any number of iPhones for an aircraft part, anything between 2 and 5, both countries are going to agree to that. So anything in between 2 and 5 in terms of trade for an aircraft part, 2 and 5 iPhones, we're going to have trade exist. Both countries will be better off trading under these terms. Okay. Is that the logic making sense? And I'll give you some numerical support here in a second. Okay. Now we can also do it on the flip side. Let's say I was doing an aircraft part. How many aircraft parts would the US be willing to give up for an iPhone? Well, if we go back here, every iPhone was going to cost the US half an aircraft part. So anything less than half, they're actually better off trading than doing it themselves. And then for India, how many would they be willing to accept? Well, if they produce an iPhone, they're going to have to stop producing 0.2 aircraft parts. So if they're given anything above that, they're better off trading than doing it themselves. So once again, our terms of trade just ends up being in between the two costs of the individual countries. Right? So once you know the costs, you automatically should know the terms of trade. It's just in between those two costs. Okay. So how does this make each of them better off? Or how can we maybe prove to ourselves with some numbers? Okay. So let's assume, excuse me, and you could start out at different combinations than these 2 points. These are just 2 that I chose that I think illustrate it pretty well. So let's say the India, it's a closed economy, nobody's trading. They're only, if they use all their resources, one of the points on their production possibilities curve we could calculate is 25 iPhones and 5 aircraft parts. Remember why? Because if they wanted 5 aircraft parts, each one was costing them 5 iPhones. So instead of 50 iPhones, they're only producing 25, and they're only getting 5 aircraft parts. For the US, if they wanted to produce 15 iPhones, right? How many aircraft parts were they giving up? Well, every iPhone, I believe, was costing them a half of an aircraft part. So to get 15 iPhones, they're going to have to give up 7.5 aircraft parts. That's where I'm coming up with these 2 values. It's just going to be 2 different points on each country's individual production possibilities curve. So before trade, this is the scenario that we live in, right? This is the number of goods each country can produce for itself. Let's assume that instead, each country only produces what they have a comparative advantage in. So now everyone's producing what they can produce at the lowest cost. We're really like using our resources more efficiently. And then we allow them to trade. Let's just, for the sake of this example, say they agree upon 3 iPhones being the value. We know it's going to be anywhere in between. What did we say? 2 and 5. Let's say they kind of, choose a number in the middle. They both agree to 3, right? So if they do that, if the US is only producing aircraft parts, so if we go back to the values we had earlier, if they only use a resource, they can get 30 aircraft parts, but now they agree to give 5 of them to the India, and in return, they get 15 iPhones. So now the US would have what? 30 minus 5, so 25 aircraft parts and 15 iPhones that they got from India. If India is only producing iPhones, I believe we said they could produce 50. So if they give up 15 iPhones, they now have 35 remaining. But giving up 15, they were getting 5 aircraft parts from the US. This is why I chose these numbers, because notice after trade, the US has kept their number of iPhones the same, but they have more aircraft parts. India has kept the amount of aircraft parts they have the same, but is now getting more iPhones. So both countries, if you have the same of one of the goods and more of the other, you are better off, right? Now, who is a little bit more better off here, right? Well, that terms of trade of 3 was a little bit closer to one than the other. We won't kind of dive into who benefits more or benefits less, but you can kind of imagine, the US would like to get as many iPhones as possible for their aircraft parts. So they'd like it to be closer to 5. India would like it to be closer to 2. 3 is a little closer to 2 than it is to 5. So this benefits India a little bit more. I won't ask you those types of questions, but that would be kind of the next level, right? And the practice of this, how do we arrive at 3? Well, there's a lot of negotiations. That's a whole different class, But we can at least understand here, if we are able to come to an agreement in that range for our terms of trade, both individuals or both countries in this example would be better off. Okay. So, oh, you know, like free trade, those are some sweet Nikes you have on, right? So free trade, you know, is going to benefit everybody, you know, despite what you might hear politically at times. Okay. So we're going to go through two more things today. Let me think of what order I want to do them in. I know what order I want to do them in. So let's just use the two country example for a second, and then we'll make this, I'll kind of add to it. So let's say we've got, oh, what do I want here? Let's do aircraft part on our x-axis, and what was the other good we were just looking at? iPhones. So in our example, when both countries were producing iPhones, how many total would we have? I think it was 50 from India, 60 from the US, so 110. Right? And then aircraft parts, if they were both only producing aircraft parts, it was what? 30 and 10, I believe, so 40. Now, it won't be a straight line in between. So this is, instead of one country's production possibilities curve, we're thinking about the worldwide production possibilities curve. So here we're adding, here I've got a simple two countries in the world. There's obviously more than two. I'll show you what that would look like in a second, but let's just assume we have two for now. So who am I going to rely on to first start producing aircraft parts? Whoever can produce them at a lower cost. Who had the lower cost? If I remember right, the US, it cost them 5 iPhones. India, it cost them 2. So who's going to first start producing iPhones? Whoever can produce it at a lower cost. So we'll eventually, initially have a slope of -2 for our production our worldwide production possibilities curve. Now, at a certain point, India has used all of their resources to produce, or sorry, I flipped these, didn't I? I did, I want, oh, I think I missed the, what was this? So I want aircraft parts. The US, it cost them 5, 2, no, this is what I want. So, sorry. So they're only producing aircraft parts, right? No, it should be whoever has the comparative advantage is producing them first. Now I have to go back and look at my numbers. So I had what? Cost of one more aircraft part was, am I flipping these countries? 2 iPhones for, oh, I am flipping these countries. I was going to say, wait, this doesn't make any sense. Sorry. I should have looked back at the actual numbers. 2 and 5, right? So it's not India who has the lower cost. It was actually the US. Okay. Sorry about that. Okay. So who are we going to rely on initially? Who can produce these at a lower cost, which was the US had the cost of 2, not 5. So initially that slope will be relatively flat. Now, at a certain point, the US is using all its resources to produce aircraft parts. They've given up all of their iPhone production. And this point in the middle here is going to be where each country is only producing, and this is without trade, they're only producing what they have a comparative advantage in. If I want to go past this point, the US has now used all of its resources. I'm going to have to start relying on the other country, India, who has a higher cost. And now my production possibilities curve is going to be a little bit steeper. Okay. So when we start to look at the worldwide production possibilities curve, or what we kind of think about as an economy-wide production possibilities curve, it's not just going to be two countries, right? It's going to be every country in the world. So if we had this same kind of setup, but we had, you know, every single country in the world, we'll first rely on who can produce it at the lowest cost. So it's going to be a pretty flat curve. Then the next lowest cost, that country uses all of its resources. Next lowest cost, next lowest, until we get out to here. Now we're relying on countries that can produce it at a really high cost. If we want more aircraft parts here, we're relying on countries who can do it at a really, really high cost. So our economy-wide or like our worldwide production possibilities curve will not just be a straight line, it's going to have this kind of bowed outward shape to it. Okay. And it's a direct result of we rely first on who can produce it at the lowest cost until they've used all their resources, then who can produce it at the next lowest cost until they've used all their resources. It's just in practice, we have a lot more than two countries, so we end up with like a lot more segments here that make up our production possibilities curve. And you can do a similar thing, not just with countries and worldwide, but every individual, like let's say instead of, we think about how many labor hours every individual is putting towards a certain product. Some individuals would have comparative advantages in the production of different goods. So we'll first rely on whoever can produce it the cheapest, then the next lowest cost, then the next lowest. So if we took every individual's production possibilities curve, say every individual in the US, and then kind of graph that, then we would have like the US economy-wide production possibilities curve. Just here, instead of individuals to country, we're going from countries to worldwide. Any questions on this before we keep moving? Let me make sure I said everything I wanted to there. Yes. So I've got a slide that kind of outlines this kind of with bullet points. For the sake of time, I think I'll just show you the visual and then we'll kind of look at that summary here in a little bit. So it doesn't matter what two goods we're looking at. I've got aircraft parts and iPhones here, but this could be any X good and any Y good. If I'm looking at this economy-wide production possibilities curve, every point on this curve represents points that are what we call production efficient, right? Because we're using all of our resources to produce these two goods. Now, there's different possibilities that we could be production efficient here, 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 or even here, right? So one thing we won't talk about today, we'll talk a little bit more about tomorrow, is the idea of, well, what's the best point to be at on this curve? We'll end up calling it, what point is going to be allocatively efficient? But for now, any point on this curve is what we would call production efficient. We're using all of our resources. Nothing is just laying around going to waste. Now, let's say I was at this point. I'm using all of my resources. This point here would represent having the same amount of this X good, but more of the Y good. Well, if I was using all of my resources and I only had this much of X and this much of Y, I don't have enough resources to go past this curve. This point is what we would call unattainable. I don't have enough resources to produce this combination of these two goods. Okay. And then a similar idea, kind of think about here, what would this point represent? Well, I have the same amount of X, I've got less of Y. Well, if I was using all of my resources here, it must be that I'm now not using some of my resources. So this is what we would call production inefficient, right? Any point underneath the curve is inefficient. Any point on the curve is production efficient. And any point above the curve is what we're going to call unattainable. Hold on, the lights are turning off on here. I got to figure out where the sensor is in this room. So these are kind of our three ranges, okay? Production efficient on the curve, inefficient below the curve, unattainable above the curve, okay? Any questions on that? Okay, so that's kind of summarized here. This mentions, when we're looking at the economy-wide production possibilities curve, it starts to kind of have this bowed shape, right? I don't know, I had some dumb example where like, who are we first going to have write songs in our society, songs versus economic papers? I'm not going to be, the first one. The cost to me of writing a song, I'd take all my time and I probably still couldn't write a good one, right? So this is the idea that we first rely on whoever has the lowest cost to produce the X-axis good, and then start to rely on the next person with the next lowest cost and so on and so forth. Well, if the slope represents costs, then we're going to end up with this kind of bowed shape production possibilities curve. Right? And then we said any point below would be inefficient, any point above is unattainable, any point on the curve we're going to say is production efficient. Okay, so that's kind of what I drew out here. You can kind of think about there's three quote unquote zones. The one zone is really just the line itself, right? That's production efficient. This area, production inefficient, and then the area above it, unattainable. Okay. So this was kind of in the complete version of the slides. Very last question of that quiz is which of these points would be inefficient? Well, C and B are on the curve, so those would be production efficient points. A is above the curve, it would be unattainable. D is below, that would be the one that is inefficient. Okay, so we've got D is the point that's inefficient, 0.75 was that cost we calculated, and then 600 was the total number of guns in this question. That should be, like I said, make sure you're getting these, I've published it already, get your answers in, get those easy points for kind of watching the lecture, watching me work through these problems. Excuse me. I won't always kind of do this kind of summary at the end. Sometimes we'll work on all the questions in the middle just to make it a little bit more difficult for people to just take the easy way out. And also kind of seeing these problems work through, I think, you could see similar stuff on the quiz, similar stuff on the exam. So kind of taking these seriously. I'm talking to the wrong people though, for those of you who are currently here because you're watching the live lecture, participating. But if you have to watch them after the fact, make sure you're kind of really paying attention to when we work through these problems. All right, so this is where I ended my earlier section. We'll talk about allocative efficiency tomorrow. I'll kind of revisit this idea of the production possibilities curve and the fact that it's has this bowed out shape. But we'll cover that. Changes to the PPC, some other stuff. Honestly, tomorrow we might have a little bit of extra time. If we do, I might start module 3 just to give us a little bit more cushion. The more material we get through, the more time that we'll have to do review next week for the exam. So other than that, make sure you get that module 2 reading done before we start class tomorrow. The module 3 reading will be due before we start class on Thursday. And other than that, there aren't any other questions. We'll end this here a little bit early. Okay. All right, so I'll stop